Here is an interesting question. To maximize a, which is equal to 4x plus 3y over z, and is subject to x squared plus y squared minus z squared equal to 0. So this is our objective function. This is our constraint condition. Now here I'm using three methods to do. Method one is use substitution. I'll let u be x over z and v be y over z. Then our a will be equal to 4u, right? This is 4u plus 3v. Okay, and our constraint y square x square. So u square plus v square will be equal to x square plus y square over z square, right? which is equal to 1, because z square equals to x y square. So therefore, our question changes. We change the fraction to maximize a, which is equal to 4u plus 3v, and the subject to u square plus v square equals to 1. So this is our objective function. This is our constraints. U square plus v square equal to 1 is a circle, right? This is u, this is v, this is v, and the radius is equal to 1. Now, a, 4u plus 3v is a straight line. The slope is minus 4 over 3. So this is a straight line. The slope is minus 4 over 3. Yeah. And of course, there are many other lines. See, all those lines bearing same slope, same gradient. So in other words, A is a family of straight lines. They all have a slope of minus 4 over 3. Now, since we are looking for maximum A, therefore we want to find a straight line is as high as possible. The higher the straight line is, the larger value A is. But we have to constrain, we must satisfy this equations. In other words, the straight line must touch the circle. So the highest value of A before leaving the circle must be a tangent line. A tangent line, this is our A maximum. Right? This is A maximum, which is a line from this family, and at the same time that it satisfies this constraint. So how do we find this point? Very easy, because this is a tangent line. Therefore, it must perpendicular to this straight line, right? Since the gradient, the slope is a minus 4 over 3, therefore this slope must be equal to 3 over 4. They must be, reciprocal negative, right? Negative reciprocal, the slopes. So this line is equal to v is equal to 3 over 4 u. That slope is 3/4, right, passing through origin. Okay, so we can find the tangent point to solve these two. Plus v equal to 1, and v is equal to 3 over 4u. Yeah, and we have two solutions. One is u equals to 4 over 5. V is equal to 3 over 5. That is this point. And also at this point, right? This point is u equal to minus 4 over 5. V is equal to minus 3 over 5. And at this point, it gives the A minimum. This point gives the A maximum. Since we are looking for maximum A, therefore maximum A is equal to 4x plus 3y over z at the point, right, 4 over 5. No, I should write this one because we changed the object function. It's a 4u plus 3v. Right? Then at 4 over 5, no, and 3 over 5. So this is equal to this one here, put this one here. This is equal to 5, right? So this is our maximum value of A. Okay, so we find the maximum, and this point gives the minimum. Yeah. So this is method 1. Method 2. Okay, this is the question. Method 2, we are using what is it called? The Cauchy inequalities. The Cauchy inequality is this: ax plus by square is less than or equal to a square plus b square multiply x square plus y square. Okay, that's Cauchy inequality. Now then, our our function 4x plus 3y square is less than 4 square plus 3 square times x square plus y square. So then this means 4x plus 3y square less than 25. Xy plus y square equals z square. So this is z square. So this means that 4x plus 3y over z, right? So less than or equal to 5 and 5. See, because 25 square root. So since we are looking for maximum value, therefore the maximum will, therefore maximum A is equal to 5. All right, this is a second method. Now the third method, while we're using the Lagrange multiplier. Lagrange multipliers is first we have to establish a multivariable function, which is this lambda of x, y, z, and lambda, which is equal to 4x plus 3y over z plus lambda times x squared plus y squared minus z squared. Okay, this is objective function. This is a constraint. So we have L. Then the partial derivative of L with respect to x. That is the derivative with respect to x. This will be 4 over z, right? Plus 2 lambda x equal to 0. So we have lambda equal to 2 over minus 2 over zx. And the partial derivative of L with respect to y equal to 3y plus 2 lambda y equal to 0, which gives us lambda equal to minus 3 over 2yz. And from these two, we can eliminate lambda and makes y is equal to 3x over 4. Okay, therefore x squared plus y squared is equal to z squared, right? Yeah, this x squared plus y squared equal to z squared. This equation is, is equal to x squared plus 9 squared over 16 is equal to z squared. Therefore, z squared is equal to this plus this, right? This equals 625x squared. So z is equal to plus or minus 4, 5x. Yeah, absolute value of x. Well, since we are looking for maximum z, therefore maximum a rather, maximum a is equal to 4x plus 3y over z, right? And which is x, 3x, and 5x. Because we're looking for maximum. Z is this. And this gives 5 over 6x, 4x, plus 9x over 4. And finally, we simplified, we give x. So the maximum a is equal to 5. Well, it's good. I've solved this equation by 3 methods.